All right. Hello, everyone. I hope you are having fun. Imagine this. There is a command line running in your environment. It's a PowerShell command, harmless, right? IT admins uses it every day. It's running on a normal schedule with the usual system privileges, downloading a file. Will your security tools catch it? Probably not. And this is the problem. Legitimate tools can be the biggest blind spots in security. So how to detect threats when everything looks so normal? This is what I will dive into today. I am Vaishali, and I'll be sharing the details of our approach that we use to detect threats in data centers. So let's start with discussing what is the problem, what is the challenge we have in centers compared to the endpoint servers. So in endpoints, we do have user-driven activities where it is still easier to set up the context to understand the baselines of the user behavior. But data centers, on the other hand, are completely non-interactive and highly automated. And this is because, and due to this, the traditional security tools end up raising a lot of false positives. In addition to this, we have short-lived workloads, and we often lack uniform visibility across the workloads in some cases. Um, on top of the things, we don't have any labeled data set, which makes things even worse. So we needed a framework that can detect the anomalies in a scalable manner and in an automated environment. That's where SCADE comes in. So SCADE is a dual-layered anomaly detection framework that consumes the data of Azure security logs, and the data is of process creation events, and it passes them through two layers. So one is global analysis, where we have the statistical methods such as log 25 and log entropy and BM25, and we try to establish the behavior of those events. We try to understand the behavior of those events from a global perspective, all across the workloads. And how do we do this? We basically understand the context of that running command from multiple angles, like based on, compared to history, is this an unusual command? What about the lineage of this command? Has it been triggered by an unusual process? And has it triggered any unusual child? What about the subjected user ID of this command? Are there any unusual combinations of parameters within this command? So based on all these factors, we assign a rarity scores to all those commands. But this is the point. We do acknowledge that rarity doesn't mean maliciousness. And that's where the second component, local analysis, comes in. So in here, we only take a look at those commands which are flagged by global analysis phase, and we try to establish the baseline and do the behavioral analysis of only the flagged asset as an individual unit, only the flagged command line, and the subject user ID. And after following this particular component, we are able to eliminate rare yet benign activities, and we only raise the alerts for malicious, highly confident scenarios. So why SCADE? Why not any other unsupervised approach? So first of all, SCADE works without the need of any label data. Second, due to its dual-layered nature, we are able to reduce the false positives. Third, we do have a concept of explainability. So when we say something as malicious, unusual, we just don't provide the scores. We explain the reasoning behind it. Next, we don't have the static thresholds in our environment, in our framework. Everything, the thresholds about what is benign, what is legitimate, all that is decided at the execution time itself. And last, it scales. Now, to validate the effectiveness of our framework, we had conducted a POC using the real production Azure data centers nodes data in combination with red simulation team exercises. And the scope of our POC was to identify malicious usage of certutil for certification dump and export primary key files. And to give you an overview of our data, we had 18 million nodes running in production every day, which are generating 31.3 billion events. Out of it, 74 million events use certutil, and 1,000 or 1,500 plus basically use, they do certification dump and export primary key files. Now, when we ran SCADE for over 2 days of the data, we only had 5 alerts raised in the environment with 98% precision. Along with this, we also were able to identify and discover some unnoticed and unethical processes that were running in production for over a year. That proves SCADE isn't just identifying anomalies, it identifies the right ones. So while SCADE is highly effective, there are still some open challenges to discuss. So for example, how do we identify the attacks in even more advanced scenarios? How do we understand the intent of those commands that are running in the data nodes? But for now, that's all from my side. I would love to continue the discussion offline. So you can connect with me using the first QR code on your window, and you can read more about this particular topic through the second QR code, which will take you to my archive publication. Thank you.